Hey everyone! In this video, I'm going to be talking about the Pythagorean Inequalities Theorem. So what I'd like to do is start by talking through what the theorem says, and then provide a little bit of justification so we can make sense of this and know that this theorem is true. And then after doing that, I want to take a look at a couple examples where we're going to be using the Pythagorean Inequalities Theorem. So to start off with, let's talk through what this says. So we already know the converse of the Pythagorean theorem is also true. So if I have my side lengths of my triangle, and if I plug these into the Pythagorean theorem, and we have a squared plus b squared, and it does equal c squared, as long as that equation is true, we know that we have a right triangle. Now, what if we don't have a right triangle though? That's what the Pythagorean Inequalities Theorem is going to do for us. So what this is going to give us is a way that we can test to see if we have a right triangle, an acute triangle, or an obtuse triangle. So long as this equation is true, we know we have a right triangle. But now let's change things up a little bit. So let's say that I take one of these sides. So this angle down here, this would be my right angle. But now let's shrink that angle a little bit. So now this is becoming less than 90, which is going to make this an acute triangle. But because I'm tilting that side in, to make up for that difference, I need to shorten up this side length. So my angle is getting smaller, but my side length of C is also getting smaller. So now this is less than 90, this is an acute angle, but now c squared is also shrinking. So what that means is a squared plus b squared, this is bigger than c squared now. And if that inequality is true, what we end up with is an acute triangle. So because I'm making that angle smaller than 90, the side across from that has to adjust. It has to also shrink to make up for that difference. So now we end up with a squared plus b squared is bigger than c squared. And for our last one, we're just doing the opposite. So now instead of a right angle, let's make that angle a little bit bigger than 90. So now that angle is more than 90, and then to make up for that difference, I need to increase how long my side length of C is. So here we have a squared A, and then B, and then this is C. Now the angle here it's opening up and it's bigger than 90. So to make up for that, the length of C also has to get longer. So now a squared plus b squared, this is smaller than c squared because c squared is bigger now. And if that inequality is true, we end up with an obtuse triangle. So this is what the Pythagorean inequality says. It gives us a way that we can test to see if we have a right triangle, an acute triangle, or an obtuse triangle. So let's use that, and let's take a look at an example. So I have three sets of side lengths, and I want to test out to see if these three are going to make a right triangle, an obtuse triangle, or an acute triangle. The first thing we actually have to do is we have to make sure that these three side lengths can in fact form a triangle. Not any three sides can make a triangle. The triangle inequalities theorem says that when I add up the two smaller sides of a triangle, it has to be larger than the third side. If that's the case, then the side lengths do form they do form a triangle. So I need to make sure that 2.1, if I add that to 2.8, that has to be bigger than 3.5. If it's not, these can't form a triangle. 2.1 and 2.8, that is 4.9, which is plenty big enough. So that is greater than 3.5. So yes, this can form a triangle. But now we want to test to see if this is a right triangle, an obtuse triangle, or an acute triangle. To do that, we're going to plug it into the equation a squared plus b squared is equal to c squared. Now we're not exactly sure if they are equal, So I'm just going to put a little question mark over my equal sign because we're testing to see what's going to happen. Now the longest side, remember that has to go in for C. That's our potential hypotenuse. And the hypotenuse of a right triangle is always the biggest side. So 3.5 is going to go in for C. My other two are interchangeable. So let's do 2.1 squared plus 2.8 squared. And then maybe that's equal to 3.5 squared. Now squaring all of our numbers, 2.1 squared is 4.41. 2.8 squared is 7.84. And then on the other side, 3.5 squared, we had 12.25. So adding 4.41 and 7.84, if I add those together, we do actually get 12.25. And 12.25, we have that on both sides. So the Pythagorean theorem does work. They are equal to each other. So this is a right triangle. Okay, let's do the same thing in our second example. I have side lengths of 14, 15, and 11. So the first thing, let's just verify. The two smaller sides, they have to be bigger than the biggest side. So 11 and 14 is 25, which is bigger than 15. So yes, this can form a triangle. Now plugging this into our equation, we're going to end up with 11 squared plus 14 squared, and then we're going to compare that to 15 squared because 15 is the biggest side. So 11 squared is 121, 14 squared is 196, and then on the other side, 15 squared is 225. All right, now on the left-hand side, adding these together, we get 317, which is much bigger, so I'm going to write greater than 225. So what we end up with here, our hypotenuse is smaller than our other two sides added together. So that means that that hypotenuse is shrinking, which means that the angle across from it also has to get smaller. So that means that this is an acute triangle. And our last one, again, just to verify, we'll do our two small sides, and that has to be bigger than the longest side. So 7 and 13 is 20, which is bigger than 18. So again, yes, this can be a triangle. And now plugging these into our equation, 7 squared plus 13 squared, and we'll compare that to 18 squared. 7 squared is 49, 13 squared is 169, and 18 squared is 324. And to finish up, 49 plus 169 is 218. 218 is smaller than 324. So what we have here is now the hypotenuse is bigger. The hypotenuse is stretching out, which means that the angle across from it is now going to be bigger than 90. So that means we have an obtuse triangle. So that's how we use the Pythagorean Inequalities Theorem. Gives us a way to take a look at the side lengths of a triangle and determine whether it's a right triangle, an acute triangle, or an obtuse triangle.